Hello friends, today let us discuss about one theorem in determining the moment of inertia, that is parallel axis theorem. So sometimes what happens, it is required to find the moment of inertia of an area with reference to an axis which is parallel to and situated at some distance from the centroidal axis. Okay. For example, let us discuss that. Let us consider one area. Okay, let us consider that this G is the centroidal axis of this area, and let I be the moment of inertia of this area about this centroidal axis GG. Then let us consider that there is one more axis AB which is parallel to this centroidal axis GG. Okay. Then if suppose we want to find the moment of inertia of this area about this axis AB, then by using the parallel axis theorem, if we are knowing the moment of inertia of this area about the centroidal axis GG, we can find the moment of inertia of this area about the parallel axis AB. So in order to do that, it is required to transfer the moment of inertia from the centroidal axis to another axis AB which is parallel to it. Then the statement is like this: the moment of inertia about any axis in the plane of an area, in the plane of an area is equal to the sum of the moment of inertia about a parallel axis, parallel centroidal axis, and the product of area and square of the distance between the two parallel axes. Parallel axis. For example, let us consider that this YC is the distance between these two parallel axes, that is GG and AB. Then referring to this figure and according to this parallel axis theorem, it states that the moment of inertia about any parallel axis, that is IAB, is equal to the sum of the moment of inertia about the centroidal axis, that is IGG, plus area into square of the distance between those two parallel axes. That is according to this parallel axis theorem, IAB is equal to IGG plus A into YC square, where A is the area of this figure and YC is the distance between the two parallel axes, that is the centroidal axis GG and the reference axis AB. This is called as parallel axis theorem. Okay. Now let us go for a proof of this theorem. Now let us consider that one small elemental area of the strip whose area is say dA, and let it be at a distance of say small y from the centroidal axis. Then what is IAB? So IAB is equal to what? Moment of inertia about AB is, according to this moment of inertia definition, IAB is equal to summation of the distance of the area from the reference axis. What is the total distance of dA from AB? It is YC plus Y. So distance is YC plus Y. So YC plus Y bracket square into the area of the elemental figure is dA. So IAB is equal to YC plus Y square into dA. Now let us split it. So this is YC plus Y bracket square, that is A plus B bracket square. Hence, if we expand it, we'll get A plus B bracket square is A square plus B square plus 2AB. Hence, YC plus Y bracket square is YC square plus Y square plus 2 into YC into Y into dA, keep it as it is. Then multiplying this dA into the bracket, we get IAB is equal to summation of, first it will become YC square into dA, then plus Y square into dA, then plus 2 into YC into Y, YC into Y into dA. Okay. Now, so if we take individually, then it will become summation of YC square dA plus summation of, let us take the second term, that is 2 times of YC into Y into dA plus summation of Y square into dA. Now we know that Y square into dA is what? Y square into dA. So Y is the distance of this area dA from the centroidal axis GG, and dA is the area. Hence Y square into dA will give IGG, that is here, summation of Y square into dA is nothing but moment of inertia about centroidal axis, that is IGG. Then this summation of 2 times of YC into Y into dA, this can be written as, let us take 2 YC outside constant, it will become summation of Y into dA. Okay. Now let us multiplying and dividing by a. Then it will become 2 times of yc into a into summation of y into dA divided by a. Okay. Now in this above term, 2 times of yc into a is a constant, and the summation of y into dA by a is the distance of the centroid from the axis GG, because I can write this summation of y d into dA can be written as y into summation of dA by a. That is y into summation of dA is nothing but complete area, that is a. So a by a get cancels, so it will become only y. So y will remain. Hence this is the distance of the centroid from the reference axis GG. But as the axis GG is passing through the centroid, the distance is 0. Okay. As the centroid is passing through GG, the distance is 0. Hence y will be equal to 0. Hence this term, it will become 2 times yc into y into dA will become 0. Hence this above equation becomes, let us call this as say equation 1. This equation 1 will become IAB is equal to summation of yc square into dA plus, you know that summation of y square into dA is IgG. Okay. Hence this can be written as IgG plus yc square is constant, take it outside, into summation of dA. But we know that summation of dA is nothing but sum of all the elementary strips which will make the complete area, that is A. Hence summation of dA is nothing but A. Hence IAB will become IAB is equal to IgG plus yc square into A. Hence this is proved. Okay, you can see that IAB is equal to Ig plus A into yc square, where what is yc? Yc is the distance of this reference axis AB from the centroidal axis GG. Okay. Now note that this theorem is cannot be applied to any two parallel axes unless one of the axis is centroidal axis. Okay. So if both are different axes, parallel axis, that is one axis is AB and other axis is CD, then you cannot apply this theorem to those two. In this case, any one axis should be a centroidal axis. So IAB is what? IgG, where IgG is what? Moment of inertia about the centroidal axis GG. Hence GG is parallel to AB. So in these two parallel axes, any one axis should be the centroidal axis. Otherwise you cannot apply this parallel axis theorem. Okay. Okay. So in the next class, we'll discuss about few of moment of inertia, how to calculate the moment of inertia for different standard figures, then for the built up sections. Okay. Thank you.